Hello, everyone. I just wanted to finish this paper, which we started yesterday. This was paper. Let me tell you the paper number. It was October-November 2019 and paper 22, 5070 O levels chemistry. So we were at this part, we were at part D. Part one has already been uploaded. Now, part D is, and hold on just a minute. So part D is that you're provided with the hydrated sodium iodide and the formula is given. So the formula is already given to you and you have to calculate the value of X. The MR is also provided, the relative formula mass. It's given as 288. So that's everything is almost given. So what you're going to do is you're going to add all of them. Sodium is 23. Then you have iodine, which is 127, and we'll check that in a second as well. And then you have 16 times 3, and then there's X water molecules. So that's X times water is 18. So it would be 18 multiplied by X, and this should sum up to be equal to 288. This should all be equal to 288. Uh, so X times 18, and I'm going to make X the subject of the equation. So it's going to become X times 18, and this entire thing would be equal to 288 minus 23 minus 127 and minus 16 times 3, and the whole thing is going to be divided by, you would have to divide the whole thing by 18. So we can make X the subject of the equation. So let's, first thing is I need to figure out whether iodine is 127 or not. So you can see over here, iodine has has a relative atomic mass of 127. So that part is fine. So let's open our calculator. It's going to be 288. So it's 288. Then you have minus 23 minus 127. And minus 16 times 3. So that's minus 48. And I'm getting 90. And I have to divide 90 by 18. So divide 90 by 18. And that gives me a value which is equal to 5. So X over here is 5. So we're done with this part of the question. X is equal to 5. Moving to the next part, which is section B now. Now, in section B, you just have to answer 3 questions. We're going to try and answer all the questions. The first one is draw the structure of butanoic acid to show all the atoms and all the bonds. So let's try and draw butanoic acid. Butanoic acid, the word but over here means 4 carbon atoms. So that's 1, 2, 3, and you have 4 carbon atom. And it's a carboxylic acid, so carboxylic acids have this functional group. So there's a double bond O and OH. Now remember, you have to make sure that you show all the atoms and all the bonds. So you could have drawn a condensed version. You could have written CH2 over here. This carbon is going to be bonded to 2 hydrogens. So show all the atoms and all the bonds. Each carbon atom is supposed to make 4 bonds. So now the structure is complete. This over here is butanoic acid. Next one is describe the movement and arrangement of the particles in liquid butanoic acid. So basically, he's talking about a liquid. What's the movement? Particles, they slip and slide past each other. Past each other. So in liquid, the particles are all sliding past each other, and the arrangement, uh, close together, loosely packed, and irregular arrangement. We'll also quickly check with the marking scheme. No, we don't have the marking scheme with us right now. Uh, Part C, the melting point of butanoic acid is -4 degrees centigrade. The boiling point of butanoic acid is 166 degrees centigrade. Deduce the physical state of butanoic acid at zero. Explain your answer. So the physical state, remember if the temperature is between the melting and the boiling point, which in this case it is 0 degrees centigrade, is going to be somewhere in the middle. So the temperatures, any temperature that's between the melting and boiling point, the substance is going to be a liquid at that point. It's going to be in liquid state. And the simple explanation that you're going to give is uh, that the temperature is higher than the melting point and lower than the boiling point. Next part is in part D, the equation for the reaction of butanoic acid with sodium carbonate is shown. So the reaction is given, and a student added 5.28 grams of butanoic acid to 56 cm cube or zero point 0.5 mole per dm cube sodium carbonate. And you have to show by calculation that butanoic acid is in excess. Uh, so what's given is you're given the concentration and the volume of sodium carbonate. So you can find the moles. So let's find N, the moles of sodium carbonate. So the formula for moles is concentration multiplied by volume. The volume must be in dm cube. So let's do that. So the concentration given is 0.500 mole per dm cube. Remember to everything must be written to three significant figures. So always be careful. Don't write this as zero point 0.5. It's a good habit that you write it to three significant figures. The value doesn't change, but it shows that you know your significant figures. So it should be written as 0.500 even in your working. The other thing is 56 cm cube. That is going to be divided by 1000. So let's find the moles. Take out my calculator. It's zero point 0.5. So it's 0.5 star 56, and I get 28. And this 28 has to be divided by 1000. So that is going to be, so it's going to be 0.028 moles. So you found the moles of sodium carbonate. That part is done. It's coming out to be 0.028 moles. Now that part is done. Now according to the ratio, uh, the amount of butanoic acid should be double that. It's 1:2. So I'm going to find the moles of butanoic acid according to the ratio, the required amount. It's 1:2. So the amount of butanoic acid, one molecule requires two molecules of butanoic acid. So 0.028. I'm going to double 0.028. So let me double 0.028. 0.028 would be multiplied by 2, and I get 0.056 moles. So I'm getting 0.056 moles of butanoic acid. You can show in the working. Um, Now that's the moles of butanoic acid that are required. And I can find the mass of this butanoic acid. How do you find mass? Mass is moles multiplied by the MR. So let's try and find the mass. So we're going to do moles 0.056 and multiplied by the MR. Trying to find the MR, it's can start calculating it's 3 carbons, so that's 12 into 3, that's 36. Plus it's a if you look over here, there's 7 hydrogens, so that's 7 into 1. Plus there's another carbon, so that's another 12. Plus there are 2 oxygens, so that's 16 into 2, that's 32. Plus there's one hydrogen at the end as well. So this is uh, so this is and let me simplify this before moving to the calculator. This is going to be 36 plus 12, that's 48, plus 32 plus 8. So 36 plus 12, that's 48, and you add in the others. It's 32 plus 48 is 80, and that would be 88. So it's going to be 0.056 multiplied by 88. Let's do that now. So 0.056 multiplied by 88, that gives me 4.928 grams. So it's 4.93 grams. Let's round to three significant figures. So it's 4.93 grams that's required. And as you can see, the mass of butanoic acid that's being used is a lot more. It's 5.28 grams. So that is 5.28 grams is greater than the required amount. So we're going to just write a statement over here. Only 4.93 grams are required. Not 5.28 grams. So it's obviously which is in excess. So we've done our working. Let me recap quickly. We found the moles of sodium carbonate first because volume and concentration were given. We used the formula for moles and we found the moles of sodium carbonate. Once we did that, we then tried to figure out the moles of butanoic acid. So it's 1:2. So the moles of butanoic acid were double that. And once we had that, we figured out the mass that was required. It was 4.93 grams multiplied by the MR. And we then realized that they're using 5.28 grams, which is more than the required amount. So it's an excess. You're adding too much. Next part is magnesium reacts with butanoic acid. The product is magnesium butanoate and hydrogen. Construct the equation for this reaction. So the reaction is magnesium butanoic acid is C3H7, as they've already given you the formula COOH. Now this H is going to be substituted by all carboxylic acid reactions. The carboxylic acid group H will be substituted by magnesium. So the product would be C3H7, COO minus 1 and Mg2 plus. And using crisscross, the formula should be this. And hydrogen gas would be released. So you would have to double this. This is going to be your complete equation, and it's a balanced equation. Remember, all acids, all carboxylic acids, they're going to behave in exactly the same way. This H would be substituted by the positive ion, which usually is the metal. So metal plus acid produces salt plus H2. Next one is one method of determining the pH of aqueous butanoic acid is by a pH meter. Describe a different method of determining the pH of aqueous butanoic acid. Now, one is pH meter, the other one, remember you're trying to measure the pH of aqueous butanoic acid. So the other one could be, it could be a universal indicator paper. So red indicates strong acid, whereas orange would indicate weak acid. So that's universal indicator papers. They and green indicates that it is neutral, and so on. Blue indicates that it's mildly alkaline, and purple indicates that it's very alkaline. So your universal indicator paper that tells you the pH of a particular substance. The next question is, so the next question is about the contact process is made by the contact process. Name the catalyst used in the contact process. So remember every detail about the contact process. It's vanadium pentaoxide or vanadium 5 oxide. Describe how and explain why the position of the equilibrium in the reaction is altered when the temperature of the reaction mixture is increased at constant. So you're increasing temperature. Temperature is increased. So if you increase temperature, Le Chatelier principle states that endothermic reaction is favored. always the endothermic reaction is going to be favored. Now, in this case, the endothermic reaction is going to be the backward reaction because if you can see over here, the forward reaction is exo. So that indicates the forward is exo, the backward must be the endo. The forward has a negative sign. So the backward one would be the correct one. So endothermic reaction is favored, which in this case is hence backward reaction is relatively faster. So hence backward reaction is favored and position of the equilibrium shifts to the left. So position is shifting to the left. The next part is the pressure of the equilibrium mixture is increased at constant temperature. So when you're increasing pressure, if you increase pressure, Le Chatelier principle, when you're increasing pressure, you're basically decreasing volume. You're squeezing the substance. So if you increase pressure, uh, less gas mole side would be favored. So if we go back and have a look, which side is less gas moles? If you look over here, this side has 2 moles of gas. The other side has, remember, count the moles of gas. The other side has 3 moles of gas. So the less gas mole side is this one. So it's going to be the forward reaction that's going to be favored. So if you increase pressure, less gas mole side is favored, which in this case, hence forward reaction is favored. And if forward reaction is favored, position shifts to the right. It's going to shift to the right hand side. Anyways, the next one is the final step of the manufacture of sulfuric acid is an exothermic reaction. On the axis, draw a labeled energy profile diagram for the exothermic reaction. Now you have to exothermic reaction. The reactants have greater amount of energy compared to the products because energy overall is being released. So these are your reactants over here, and on the other side, you're going to have your products. So you have reactants on one side, products on the other side, and there's going to be a curve which is going to come like this. Uh, and you have to label this. You have to label the enthalpy change. The enthalpy change is going to be this one over here. From reactants to products, that's delta H. And activation energy would be the energy that is initially needed by the reaction. So it's going to start here and it's going to go till this point. So that over here is the activation energy. So remember, reactions need energy at the beginning. Why? Because they need to break bonds. So they absorb energy. Any reaction, you burn a match, you have to give it energy first. You have to strike the match or you have to heat it up. So reactants need energy so that old bonds are broken. And then new bonds are formed, and that's when energy is released. The next part of the question is part D. Air is a raw material used in the manufacture of sulfuric acid. Name one other raw material used in the manufacture of sulfuric acid. So, one other raw material is sulfur. That is used, and state one major use of sulfuric acid. It's going to be lead acid. Batteries. I'm going to check this answer quickly. D. Just wanted to try and figure out what do they mean by the word raw material. So I'm going to open the marking scheme for this paper, which is 5070. So let me quickly open the marking scheme. So it's 5070. So here's the marking scheme, and we were on section B, the first question in section B. So the first, so it is sulfur. 7 part D, that's simply sulfur. They weren't actually looking for the ore. That was just sulfur. Anyway, so we've done with this part. Let's move to the next part. Question number 8. Now this question is about phosphorus, and the first part is easy. You just have to figure out the number of electrons. That's 15. The number of neutrons, so that's 31 minus 15, so that's going to be 16. And the number of protons, so that's also 15. Next part, what is meant by the term isotopes? Isotopes are atoms of the same element. Remember this definition, atoms of the same element. And what do they have in common? Atoms of the same element having same proton numbers, but different neutron numbers. So that is what's meant by the term isotope. So here's your definition in front of you. In the next equation, you're being asked phosphorus reacts with potassium chlorate to form potassium chloride, and you have to complete the equation for the reaction. The equation is actually completed. You just need to balance this equation. So we're going to try and balance this equation. There are 5 oxygens over here, and there are a total of 3 oxygens over there. So that is the tricky part. So you multiply this by 5. So if I multiply this side by 5, it gives me 15 oxygens, and I'm going to multiply the other side by 3. That gives me 15 oxygens as well. We can then balance phosphorus, which is 6 over here, so there would be 6 phosphorus, and there should be 5 uh, potassiums on both sides. So now this equation looks perfectly balanced. Anyways, the structure of a compound of phosphorus is shown. This is the structure. Deduce the molecular formula of this compound. So you just have to sum up the atoms. So it's how many hydrogens? It's 1, 2, 3, 4, and 5. So 5 hydrogens. So that's H5. How many phosphoruses? That's 1, 2, 3. So it's H5P3. And how many oxygens? That's 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 oxygens. So that sums up the formula for this compound. It's H5P3 and O is 9. Let's move to the next part, which is part D. Draw a dot and cross diagram to show PCl3. So we need to show the diagram of PCl3. This one over here. So it's PCl3. So it's going to be 1P, and there are going to be 3 Cls. Now P has a total of 5 electrons. Cl has a total of 7 electrons. So here's another Cl with its 7 outermost electrons. And here's another Cl that's also having 7 electrons. Now, phosphorus is going to attract these electrons, and it's going to form 3 bonds with 3 of the Cls. So there's another uh, covalent bond over here and a third one over here. Phosphorus needed 3 electrons. So 3, and let me bring this upwards. So you have your dot and cross diagrams with phosphorus sharing 3 electrons each, and chlorine bonding with it. The next part is the equation for the reaction of phosphorus with copper 2 ions is shown. Identify the oxidizing agent, explain. Now, oxidizing agent is the one that gets reduced. whose charge decreases. So who's getting reduced? If you look over here, copper 2 plus goes to copper 0, so the charge is getting reduced. So the oxidizing agent is going to be copper 2 plus. And the explanation is that it gets reduced, which means it gains electrons. So it's gaining electrons, and if it's gaining electrons, it's you also explain that the charge, it actually gains a total of 2 electrons to form a copper neutral element. So given equation, although that's not required, you just have to tell that it's going to get reduced. Remember, oxidizing agents are the ones that are always gaining electrons. Now, the next part of the question, I think we are done with the questions. Just have a look quickly. That's question number 8. Uh, then you have question number. So that was one. Then you had this question. So did we do attempt four questions over here? So answer 3 questions from this section. So I think I've missed a question. Let me quickly open the paper somewhere as well. Uh, so I had this paper over here. Let me just check if we had missed a question or not. So it was I think W19 QP22 exactly. Yes. So we still have one question to go. So let's try and do that. And we're done with this. Okay, so we have one question to do. Let me copy the questions very quickly. So that's one. Uh, quickly copying the other ones. And then there's this last one over here for chromatography. Let's copy that. So let's begin. The last one, question number 9. Now name one other natural polymer. So you have to figure out a natural polymer. So what's a natural polymer? Proteins is a natural polymer. So name one other natural polymer. So complex, you can talk about starch. Starch is a natural polymer. I'm also going to briefly, just for revision's sake, I'm going to briefly tell you how a starch molecule is made from glucose. That you have these molecules, which are represented by these boxes, and the molecule has OH groups on both sides. So each molecule, whatever the molecule is, a glucose molecule is a complicated molecule. So we're not going to draw the whole molecule. We're going to represent it with a box. So, anyways, you have these molecules and they have OH groups on both sides. And what happens is condensation reaction happens. The H is lost and the OH is lost. So this H would be lost and this OH over here is going to be lost. And together they're going to combine to form a water molecule. So that's why it's called a condensation reaction. So the H would be lost and you can remove the OH from this side. Anyways, these molecules over here, they all combine to form water. These also combine to form water. The ones at the end, they also combine to form H and OH, they form water. and the rest of the groups they join up. I mean, they're missing bonds now, so they start linking up. They start linking up, and you have this structure of a polymer which is connected by these oxygen linkages. So that's your complex carbohydrate structure. That's what starch looks like. Describe how proteins can be hydrolyzed to amino acids. Simply, any protein can be broken down. You heat it with dilute acid. Heat it with dilute acid, and the protein will get broken down. So you can have a look, check our answers as well. We were at so heat with hydrochloric acid. That's it. So that's how you're going to break a protein. Now the structure of the amino acid alanine is shown. Alanine can be polymerized to form polyalanine. Draw the partial structure. So you have alanine. Now all amino acids have this thing. They have a carboxylic acid group on one side, and they have an NH2 group on the other side. One side there's a H, and the other side there is R. That is always usually this R is, over here is being represented by CH3. Anyways, what we are interested in is this part. All amino acids, the reason they're called acids is because they have a carboxylic acid functional group. And the reason they're called amine is because they are amines, they have NH2 group. So I'm going to draw a couple of more repeat structures. They've actually told us to draw two repeat units. So let's stick to what they have told us. So this other one also has the same structure. At the bottom, there's CH3. And on this side, there's going to be NH2 molecule. Anyway, so these are your two alanine molecules, amino acids, having a carboxylic acid group on one side and an amine group on the other side. Now, the same thing happens over here as well. What happens is that the H and the OH in the middle, they end up forming water. A condensation reaction happens. And the thing repeats. OH and H at the ends would be lost. I mean, there would be more repeating units, and the same thing would repeat over and over again. So I'm going to get rid of this. The middle part, they're gone. This side as well. So they have ended up producing water molecules. And they're going to link up. So bring them closer, and they link up in the middle and at the ends as well with other molecules. So imagine the structure is repeating endlessly. So there would be more alanine molecules on both sides. So the same thing would repeat over and over again. It's very important that you draw these continuation bonds. And this over here is known as your amide link. It's serial bond O and NH. That's known as your amide link. So let's move to part D now. The structure of amino acid serine is shown. Serine can form polymers with amide linkages. Serine can also form polymers with a different linkage. Name the linkage and explain how it is formed. Now, serine has an OH group. So look carefully. It has an alcohol group, OH. Plus, it's a carboxylic acid over here as well. So remember, carboxylic acids and alcohols, they can form esters. What happens is if there's a molecule and it has OH on one side, and there's another molecule which has carboxylic acid, R is the rest of the molecule, so it has carboxylic acid group on both on one side. A condensation reaction would happen, the OH and the H would be lost. So let's rub those off, and the two would join up. And that's known as an ester link. An ester link would be formed, which so this over here is an ester link. So carboxylic acids and alcohols can react with each other. So the two parts of the chains they can react with each other. So this explanation for the linkage is that it's going to be an ester link. The other part is explain why, because alcohol group and carboxylic acid group. would link up to form an ester. ठीक है? Hopefully it's just a 1 mark question, this part. So the explanation would be sufficient. What did they write? Just this, that the alcohol and carboxylic acid group. So we've mentioned that. So this part is done. You've got marks for that. Now the other part is paper. This probably is the last part. Paper chromatography can be used to separate a mixture of amino acids. The apparatus used is shown. Why should the baseline be drawn in pencil and not in ink? Ink is soluble. That should be sufficient. 1 mark. Ink is soluble. Pencil is not soluble in the solvent. In the solvent. So that pretty much sums this up. The next part is when the separation of the amino acid is complete, the chromatography paper is sprayed with a locating agent. Now you're trying to identify amino acids. So the problem with amino acids is that they are colorless. They are colorless, and since they are colorless, you need locating agents, which make them colored. Um, so they're colorless, and you can't really see them. So even if you get a chromatogram, I mean, even if an amino acid travels upwards, you wouldn't be able to see it. So that's why a locating agent is a must. Anyway, so actually, there's another one. There's another question coming up. The diagram shows the chromatography paper after it has been sprayed with the locating agent. So you start seeing these amino acids, calculate the RF value of the amino acid labeled S. What you're going to simply do is, I don't have a ruler with me, but in your exams, you're going to have a ruler. What you're going to do is measure the distance from the baseline. Measure this distance. Let's assume that I'm getting 4 centimeters on my ruler and measure this distance, the solvent. How much is the solvent traveling? So my hunch is that it's approximately traveling 5 centimeters. Now remember, this is I don't have a ruler. I'm not. You're going to use a ruler. You're going to use a ruler on your paper, and you're going to measure these distances. So what's the RF value? RF value is the distance of the dye divided by the distance that it has been traveled by the solvent. And starting from the pencil line, not from the solvent level. Remember, not from the bottom. It's always going to be where you initially put the baseline is the place where you initially place these dyes. Anyways, we're going to use this formula, so the RF value would come out to be 4 over 5, which is 0.8. And that is going to give me the value. So that's what I'm going to write over here. So now we're done with this paper. We're finished with this paper. I'm going to try and solve, whenever I get time, I'm going to try and solve the next paper related to chemistry.